Can you see my screen? Can you see my screen? Hello, boys. Can you see my
Yes,
screen?
sir.
Okay. So today probably I will try to complete the chapter by showing you how to do some numericals based on this chapter, chemical thermodynamics. Today is the 8th day of myself transacting the lesson chemical thermodynamics. It's a Monday, 22nd of November 2021. Okay. Now, if possible, please, keep your writing materials and exercise copy so that you also copy. And when I solve the problem, the numericals, then you also do them and so that you can understand it properly. Okay. So numericals. So we'll begin with the numericals for today. Numericals. Chemical thermodynamics. Chemical thermodynamics. Okay. Now, the first numerical, please copy it down. Okay. The question is like this. For the reaction, the equation is given below. Twice CO plus O2 it is forming carbon dioxide gas, and the enthalpy change for this reaction is given minus 560 kilojoule. Okay. Now the question is like this. 2 moles of carbon monoxide and 1 mole of oxygen are taken in a container in a container of volume 1 liter. 1 liter. They completely form 2 moles 2 moles of carbon dioxide. The gases deviated appreciably from ideal behavior. From ideal behavior. And also, if the pressure in the vessel changes from 70 to 40 atm 40 atm atmospheric pressure, find the magnitude, find the value of, or we can say value of delta U, change in internal energy at 500 Kelvin, and given 1 liter atmosphere is equal to 0.1 kilojoule. Okay, this is given. This is the question. Now in this question, please copy it so that I'll change the screen and your question will be in exercise copies. Okay, if you don't copy the question, then you might not understand the working. So it is very important that you copy the question. I am waiting for some time for you all to copy the question. This is a reaction between carbon monoxide, complete combustion of carbon monoxide to produce carbon dioxide. The enthalpy change is minus 560 kilojoules. Okay, a minus sign is there because it indicates that it is an exothermic reaction. Okay, so these things are taken in a container of volume 1 liter. They completely form 2 moles of carbon dioxide. Nothing of the reactants are left. The gases deviated appreciably from ideal behavior. That means they are not ideal, real gases. If the pressure in the vessel changes from 70 to 40 atmospheric pressure, find the volume, find the value of delta U, that is internal energy change at 500 Kelvin. So the temperature is 500 Kelvin over here. So if you have copied the question, then we can go for the solution. So the solution is like this. Solution for this numerical. Now at constant pressure conditions, if we apply the formula at constant pressure conditions, then no, not here you have to apply the formula for enthalpy. Formula for enthalpy. Definition of enthalpy. So from definition of enthalpy, the formula of enthalpy is delta H is equal to delta U plus delta PV, pressure volume work. Now this can be expanded, delta U plus V delta P plus P delta V. Now here, what is constant? Volume is constant. The volume of the container is constant. Volume is constant. It is kept constant. So delta V is 0. Okay, so here this delta V term will be 0. There is no change in volume. So this entire thing becomes 0. This entire thing becomes 0. Okay. Now we can put the values. Therefore, you can write the equation delta H is equal to delta U plus V delta P over here, V delta P. Now we are supposed to find delta U, the change in entropy, what we call internal energy. So therefore, delta U is equal to delta H minus V delta P. Okay. So delta H value, it's given in the question, negative value, minus 560. Okay, minus 560 minus 560. Okay, then after that put the other values. Volume, it is 1 liter. 1 liter. Okay, volume is 1 liter. 1. And then change, change of, what do you call this? Change of pressure is from 70 to 40 means 30. That is 30. Now, this is
I will
30.
not have minus 30.
Where?
So because pressure is
Yeah, pressure.
decreasing, so
That is
yeah,
what. Wait. There I'm doing it. Okay. Here
yes,
we'll put this in the bracket.
I
P is
understand.
there 1. So this is final volume is 40. So 40 minus 70 is minus 30. Correct. Minus 30 over here. Okay. Minus 30 is there. Now this 30 atmosphere, no? This 30 atmosphere needs to be converted to kilojoules, isn't it? Needs to be converted into kilojoules. So we multiply again by 0.1, because just now you saw 1 liter atmosphere is equal to how much? 0.1 kilojoule.
0.1.
Kilojoule, no? So now we have to convert this atmosphere, 1 liter atmosphere, because here it is 1, no? There is 1 liter, no? And there is atmosphere. So we have to convert this into kilojoules. So we multiply it by 0.1. Okay. And then simplify this relationship. So if you further simplify, you will get answer as minus 557 kilojoule. Okay, because their simplification is minus 560. This minus becomes plus, and 30 into 0.1 is how much? 3 only, no? 3 only. It is 3. Okay, so minus 560 plus 3 will become minus 557 kilojoules, which is the change in internal energy, which is asked in the question. Okay, this is also called magnitude of absolute value. Magnitude or absolute value. Magnitude, or you can say absolute value of change in energy. Absolute value. That is the answer. Value of delta U. Okay, that is the answer. This is the first sum. Okay. Just check the working whether you have understood or not. Your volume is constant. That is why P delta V. This delta V 0 means 0 into P will be 0. So that's why we are writing delta V is 0. And then from the definition of enthalpy, after delta V is 0, we put the values over here, make delta U the substitute of the formula. And volume is 1 liter. And this delta P is in atmosphere. So we convert that liters atmosphere into kilojoules, because this 560 is in kilojoules. So students normally make a mistake over here in this part. Okay, that's why you have to use what is given in the question, and if possible you can learn this also. 1 liter atmosphere is generally 0.1 kilojoules most of the time. It is a constant. Okay, that is question number 1. Now let us go to the next question. Shall we go to the next question? Question number 2. Question number 2. Question number 2. Okay, now the question is like this. 1 mole of an ideal gas undergoes reversible isothermal expansion from an initial volume V1 to final volume, that is 10 V1. Okay, and does 10 kilojoules of work. The initial pressure was 1 into 10 to the power of 7 pascals, PA. Okay. Now the question says, first question, there are two parts of here. Calculate V1. Now this V1 is initial volume, and subpart 2, if there were 2 moles of gas, what must have been its temperature? Okay, so this is the question. Please copy it so that I will do the working on the next slide. I read the question once more. 1 mole of an ideal gas undergoes, just a second. We'll continue. I am sharing my screen.
Yeah.
Can you hear me?
Yes, sir.
Okay, so this was the problem. Okay, 1 mole of an ideal gas undergoes reversible isothermal expansion from initial volume V1 to final volume is V2, 10 V1, and in expanding from V1 to 10 V1, it is doing 10 kilojoules of work, and moreover, the initial pressure is given 1 into 10 to the power of 7 pascals. Okay, so we're supposed to calculate first V1 and then the temperature for the second part. If there were 2 moles of the gas, what must have been the temperature? So the first part solution is, remember, for a reversible isothermal expansion formula, for a
So your
reversible,
voice is cracking a lot. Your
hello,
voice is cracking.
hello,
Yes,
hello, is it still cracking? Hello, can you hear me?
yes,
Yes, sir. So we can hear you properly.
Okay, for a reversible isothermal expansion, the formula which we had discussed in this chapter, W reversible, I told to remember the formulas only, not derivation part, minus 2.303 nRT, okay, log to the base 10 P1 by P2. This is the formula. Now, if the temperature is constant, in the initial case, the temperature is constant, so I'm going to write down on the next slide, at constant
not
temperature.
very complete question.
Oh, complete it. Yeah, complete it. Yeah, complete the question. Okay, I think that time the internet went away when I was writing the question. Okay, please copy it. I'll wait for you. Okay, when it is done, then let me know. For a reversible isothermal expansion, W reversible is equal to minus 2.303 nRT log P1 by P2 or log V2 by V1. Is it done?
No, sir.
What do you have in the second period, my dear boys?
So
Biology.
computer.
Computer and biology. Are you going to have biology and computer class? Yes?
Yes, sir.
You'll have no. So I'll take a little bit more time, okay? Because I lost some time over here because of the
Sir,
internet connectivity. Yes.
sir, how should we know if an or sir, reaction will be reversible or not, sir?
No, here it is given in the question.
Yes, sir, sir. If it's not given, so it will be given.
It will be given always,
Yes,
it will be given because there is work done reversibly, isothermal expansion. There is work done irreversible isothermal expansion.
yes,
These
sir.
are two cases. These are two formulas which I have. For irreversible, work done is work done of pressure. P2, no, pressure volume work. Okay, so there you have to apply P delta V volume, that formula which I had given. Okay, is this
Yes, sir.
completely clear?
Opinion.
Complete? Okay, now after that, after that, at constant temperature, T is constant. So we write over here P1 V1 is equal to P2 V2. So from this formula we'll put the values. Pressure, it is 1 into 10 to the power of 7 pascals, and volume will write V1 only, V1, that is equal to pressure 2. Pressure 2 we don't know, and we write volume 2 as 10 V1, 10 V1, isn't it? See, 10 V1. Now, don't you
Yes,
think this volume 1, this volume 1 will cancel? We'll have to 10 over there. So I can write over here pressure 2 is equal to this is 1 into 10 to the power of 7 divided by 10. Pressure 2 is, no, it is, yeah, correct. Pressure 2 will be equal to yeah, correct, 1 into 10 power of 7 divided by 10. This will be equal to 10 to the power of 6 pascals. 6 pascals. So that is the final pressure. Okay. Now we substitute the value of pressure in the formula which I have written. So substituting the value of pressure in formula which we have written that time. So we can write down the formula which we had written was this one, W reversible. Okay, this formula. Okay, so work done reversible. So we get over here that is equal to minus 2.303 into taking 1 moles into gas constant is 8.314 into temperature, we did it as T only. Okay, log and then pressure, it is 1 by pressure 2. Pressure 1 is 10 to the power of 7 pascals. This is base 10, and pressure 2 is 10 to the power of 6 pascals. Okay, so and then after that over here the amount of work done is how much? 10 kilojoules. No, this is work done. This is what? Work done. This value is 10 kilojoules. Convert the 10 kilojoules into what do you call? Joules. Okay, so we write minus. It is minus because over here what is happening? It is the gas it is undergoing expansion. The gas is doing work. Okay, so minus value over there. Minus 10 into 10 to the power of minus 3. We are converting this kilojoules to joules. So this becomes the equation after putting all the values. It's a work reversible. The work done is 10 kilojoules in the question. Just see. The work done is 10 kilojoules of work. By whom? By the gas. So that's why there is a minus sign over here. Now, upon simplification, if you simplify this equation, then you have to make T the subject of the formula. This is log 10 to the power of 7 by 6 log 1. Log 1 is how much? This is now this 10 power of 6 will cancel 7, so it becomes log 10. Log 10 value is 1, isn't it? So now this T becomes equal to minus 10 into 10 to the power of minus 3 divided by minus
Sir,
2.303s into
so that kilojoule to joule, there should be minus 3 or plus 3.
we are converting kilojoules to joules, no? Kilojoules to joule. So to divide it by 10 to the power of what? 3, no? Isn't it?
It's
Is it just check?
10,000 joules. No?
10 kilojoules is given, no? 10 kilojoules, no? 10 kilojoules. So minus 10 into 10 power of, oh, this one is just a second. 1 into minus 10, 10 power of plus 3, yes. You have to multiply it by 10 power plus 3. Just check. Okay. So
Yes, sir.
upon simplification, now you will get, if you simplify this, I am using a calculator, so I will get approximately temperature. I will get around minus will cancel, so this divide 10 power of 3 into 10 is 10 power of 4. 10 power of 4 divided by 2.303 divided by 8.314. I'll get approximately 523 3 Kelvin. This is the answer, the temperature. Okay, this is the temperature. Okay, so this is the temperature I'll get. After that, this is not the answer. This is not yet the answer. Then after getting the temperature 523 Kelvin, now ideal condition, ideal gas, no? So over here, we'll apply the formula substituting in PV is equal to nRT, ideal gas equation. Okay, so we have one pressure is 1 in 10 power of 7 into V1 is equal to number of moles, we take it as 1, and 8.314 is the gas constant, and temperature is 523 Kelvin. Okay, so then I can get the volume. That is the first answer, volume 1. If I simplify this, I will get this one 523 divided by 5, what do you call? 523 10.314 divided by 1 10 power of 7. That I will get approximately 4.34 into 10 to the power of minus 4 meter cube. Meter cube. Okay, so this becomes 4.34. Okay, 10 power minus 4 meter cube. That is the volume. First part of the answer. Okay. Then this for the second part, they have told if there were 2 moles of the gas, what must have been the temperature? So for 2 moles, for 2 moles, for 2 moles, if this number of moles is 2, then just simply divide the temperature. 523 divided by 2. The temperature becomes half. 261 point how much? 15 Kelvin. Okay, so this is the temperature for 2 moles. So this is the second problem which you have done. Okay. There are some more problems, but I think it is already time. So please try to revise till here. Just go through the steps, nicely and see how it is done. And I will take, I think, one more day tomorrow. One more day tomorrow to do 4-5 numericals which are important. Okay. Because tomorrow I have a class with you, first, second,
Yes,
third,
sir.
fourth period. Okay. So I like to end my class here only. Okay. So with this, I go ahead to the recording of the attendance for today, and then you may join the next class. Okay. After that, downloading attendance. Okay. It is downloaded. Okay, boys. Thank you so much. Have a nice day.